Hey guys, welcome back to the QSC YouTube channel. Today I'll be solving the 4.8 geometry quiz for the day after tomorrow's periodic. Okay, so for this question, from a lighthouse, ship A is at a distance of 6 radical 5 miles on a bearing of 40 degrees, and ship B is at a distance of 12 miles of a bay and on a bearing of 310. So for whenever we hear the word bearing, we draw a north, okay? So from 40 degrees, we move clockwise. So like this, something like this. This is ship A, and ship B is at a distance of 12 miles and on a bearing of 310 degrees. So this is 6 radical 5. Then to go, and then we need 310 degrees. So it's approximately something like this. Okay, just wait. So it's approximately something like this. Okay, so as we know, this is 40. This whole circle is 310 degrees. So this angle that I'm coloring here would be 50, right? Okay, if this is 50, then what is the total angle? So this angle here is 50, and this angle here is 40. And together they are 90, so a right angle over here. Okay, and this is 12, and this is 6 radical 5. But they want this. You see this big line that I'm drawing? They want this. Okay, so to get that line, we can simply do the Pythagorean theorem, because we have a right angle and we have both legs. The legs being 12 and 6 radical 5. So what we're gonna do to solve this question is the Pythagorean theorem by doing 6 radical 5 squared plus 144, or 12 squared, you can say. Then don't forget to like radical the entire thing. So when you're done with the calculations, just radical the answer and you'll get 324. Radical 324, which is 18. And number 2. Okay. A car travels from station X to a station Y 460 meters away on a bearing of 210. The distance due west the car travels is 230. So we have a station X here. Wait, let me center it. We have a station X here. Okay, so 400, so we're gonna have to do a bearing of 210 degrees, which is around right here. So let me erase the circle. Oh, so it's around here. So this whole thing is, wait, 460. But this is 210. So this angle here is 150. But they want the distance west, so they want uh, so they want this distance, like this distance from this. They want the west part from the actual thing. So what we're gonna do here, since we know this is 150, we're gonna do 4. Okay. Okay, so I updated the drawing and this whole angle is 150. Okay? So we know that this angle is actually no we don't know that. So anyway, we're just gonna do so they want this angle and we have the entire thing, but we want uh, like this angle. We know that this angle is 90, like if we draw the perpendicular, this is 90, so this is 60. So all we have to do now is cosine 60 times the distance they gave us. So cosine 60 times 460, which they gave us, which will give us 230. Number 3. Okay. From a lighthouse, ship A is at a distance of 20 miles on a bearing of 20 degrees, and ship B is at a distance of 20 miles on a bearing of 260. So let me just erase this. Okay, so from a lighthouse, okay, on a bearing of 20 degrees. So ship A is around here, this big black dot, and the distance between them is 20 miles. Okay, and ship B is a distance of also 20 miles on a bearing of 260, which means it will be around here. Okay, this is ship B. Also, this is 20, and this whole thing is 260. So now we know that the whole thing is 260. This part is 130. Okay, and if that part is 130, then this part is 110, because we know that this is 20, and the whole of this part is 130. Okay, so to find the distance between the ships, which is this, all we have to do is the cosine rule. Wait. Okay, so I fixed the drawing because the angles were kind of off. So they want this distance, okay? And we have this angle that I'm coloring right now, which is 100, right? Okay. Because if this is 260, then the rest of this will be 100. And if this is 100, this should be 120. So 20, 20. We can do the cosine rule, which is from this we can do 20 squared plus 20 squared minus 2 times 20 times 20 times cosine 120. Okay, and you'll get 1200, but that is this distance squared. We need the square root. So we're gonna do square root of the answer, which will give us 20 radical 3, which is the answer. So for this question, the angle of elevation of a vertical tower from a ship is 17. So let's say this is the tower and this is the ship. Let's draw a triangle. This angle that I'm coloring in 17. Okay, so the ship is sailing 400 meters due east. So we know that this is 400. The height of the tower, or this, we're gonna have to find it. Okay, so this angle is 17 as we said. Now, what is the height? How is the height related to the angle? As we can see here, the height is opposite to the angle. And the 400 that we have here is the 400 that we have here is adjacent to the 17. So we know that tan is opposite over adjacent. So to find the answer, we're just gonna do tan 17. So we know that tan 17 is equal to x over x, which will be the height, over 400. Cross multiplies, so we're gonna have to do tan 17 times 400. T equals to x over 400, cross multiply. So we do tan 17 times 400, but we should use like the accurate uh, the accurate values that they give us from the table. Because if you use the values we use on the calculator, we'll get to 123 or 122.9. So we're gonna have to do 0.31 equals to, just remove this and just put 0.31 and cross multiply. So 0.31 times 400, which will give us 124. Number 5. Okay. So for this question, we have A, B, C, D, X, Y, Z, W is a right rectangular prism. Okay. As a fraction in lowest terms, what is the tangent or tan of the angle between plane ADZY and plane ABCD? Plane ADZY is the one that's slanting upwards or shaded in gray, as we can see. And the plane ABCD is the one like horizontal. So the angle they're talking about that we want the tan of is YAB. Okay? So the angle YAB, they want the tan of it. Tan of YAB, tan is opposite over adjacent. The opposite here, which is 8, as we can see here, YB, over adjacent, which is 15, which is AB. Number 6. Okay, so for this question, there's multiple parts to it. For part A, we're gonna have to find AN. Okay, let's draw it here. So we have ED, which is 10, and we have AE and AD, which are both 13. To find this, we can use the Pythagorean theorem, but this will have like altitudes and isosceles triangles are also medians. So we can split this and this. We can split this whole line into two parts, which is 5 and 5. So now we can do Pythagorean theorem. We can do 13 squared minus 5 squared, which is 144. But we want like this side, not not the side squared. So we're gonna have to do square root of 144, which is 12. The surface area of AED. Okay, let's go back to the original drawing and let's add the height 12. Okay, we know that the area of the triangle is the base, which is 10, times height over 2. So all we have to do is 12 times 10 over 2. It's that simple, which will give us 60. C. The total surface area of the pyramid is equal to. Okay, look, since all of the triangles are equal, let's say, okay, so each triangle is 60. How many triangles do we have here? One, two, three, four. Okay, so 60 times 4 plus. Okay, to find the total area, like we add the areas of all of the shapes together. So we're done with finding the areas of all of the triangles. Now all we have to find is to find the area of the square, which B, C, D, E. And to do that, all we need to do is side times side, which is 10 squared, which is 100, which will give us 240 plus 100, which is 340. Now, for the last part of this question, the cosine of the angle between the two planes EAD and BAC. So for this one, I cannot really draw it, so I'm just gonna draw it here. Let's say we have two triangles touching each other. The angle they're talking about here is this one, okay? And to find this angle, we need the triangle in between, which I'm gonna highlight here, this one. Okay, so to find this triangle, we're gonna need like all of the sides. The sides we have are 12, which is AM. 12 because they're equal, and then this part, which is the diagonal of the square, which is 5. Okay, really good. So now we're gonna need this angle. So for this, we can do the cosine rule. Okay, which is cosine of the angle, which we'll name A, will be 12 squared plus 12 squared. Just wait. Okay, so as we said, but I kind of drew the triangle wrong. The triangle actually looks like this. Okay, but this is 10, this is 12, this is 12. Then as I said before, to find the angle we need to do the cosine rule. Cosine of the angle, let's call it A, is equal to 12 squared plus 12 squared minus 10 squared over 2 times 12 times 12. Let me just put it in the calculator. Okay, 12 squared plus 12 squared minus 10 squared divided by 2 times 12 times 12. and you'll get 13,536, which is what? So as I said, in cosine A is equal to 12 squared plus 12 squared minus 10 squared over 2 times 12 times 12, and you'll get 0.65277. But if you press like the button that makes decimals into fractions, you'll get that it's also 47 over 72. Number 7. This question is probably the easiest out of all of them. The bearing of P from O. Okay, so we have O. Let's draw a north or a straight line from it. From P, this is 57. So they pretty much want this angle. So what we're gonna do here, now that we know that this angle is the right angle and this is 57. So for this angle, all we're gonna do is 90 minus 57, which is equal to 33. That's it. Thank you guys so much for watching this video. Hope this exam will be easy and hope this video was helpful. Make sure to like and subscribe to this channel, and thank you. Goodbye.